Sketch the graph of these two functions. The first one is f of x equals 1 over x, and the second one is f of x equals 1 over x squared. So for the first one, let's just make a table, okay? And we'll just plug in certain values here, right? So, we always start with a smaller number, so if x is 1, right, then f of 1 is 1 over 1, which is just 1. But notice what happens as x gets larger, right? When x is equal to 2, right, we get 1/2. When x is equal to 3, we get 1/3. And hopefully we notice some pattern is going to happen, right? But what happens when x is negative 1? Right, well, we still get negative 1. When x is negative 2, we're going to get negative 1/2, so on and so forth. Okay. What happens when x is 0, though? You notice when we plug in a 0 here, right, 1 over 0 does not exist. Okay. And then we'll do a couple more. What about 1/2? Okay, so let's plug in a 1/2 like a fraction in here. Well, notice what happens, right? We get 1 divided by 1/2, which is equal to 2, right? So actually, as we get smaller, right, as x is a fraction, the function value or the output is actually getting larger and larger. So what is this graph of 1 over x going to look like here? So we'll plot a couple of these values and give you just a general shape here, right? Well, when x is equal to 1, right, y is equal to 1, here's 2, 1/2, right? Here's 3, 1/3, and we notice that these values are just going to get smaller and smaller. Okay, now we know that we can never actually equal 0, right? But notice what happens between 0 and 1. Right? When x is 1/2, y is equal to 2. When x is 1/3, y is equal to 3. So actually, these values just keep getting larger and larger. We're going to get a shape that looks a little something like this. And on the other side of the y-axis, when x is negative, right, we're sort of going to get the same thing, okay? Except our graph is going to look a little something like this. Okay? You notice when x is equal to 0, right? When x is equal to 0, the y value does not exist. So we get a shape, okay, that looks something like this here. Okay, this is the basic shape or graph of f of x, which is equal to 1 over x. Okay. Now, what are some characteristics of this graph? Okay. So, for example, where is this function increasing? And actually, when you take a look, as we go left to right, right? Remember, as you go left to right, this means the x values are getting larger, right? As we go left to right, these x values are getting larger, but notice what is happening to the y values. Oh, wait a minute, here these y values keep getting smaller and smaller, right? Okay, these y values keep getting smaller and smaller. Now 0 does not exist, right? So we can't even include that, but what happens here, right? The y values keep getting smaller and smaller. So this is actually decreasing, okay, across the whole domain, but once again, don't forget, 0 is not included. So if I ask, where is this function decreasing, we should say, from negative infinity to 0, union 0 to infinity. Because once again, 0 is not included, okay, as a function value here. Right? So this is always decreasing, right? Remember, this gives the answer in terms of the x values here, right? From negative infinity to 0, all the y values are getting smaller. Okay, we have to cut it off at 0, but then we start again here. Okay, and as we go left to right, as x goes from 0 to infinity, y values are getting smaller. Okay. All right, now what can we, does this graph show any reflections at all? And the answer is yes. Right, so this graph is actually reflective across the origin, which means that, this is going to be an odd function here. Okay. What does that mean? It means for every value here, right, for every value that we pick, okay, we can pick a value, but then it'll just be reflected across the origin, which means that the x and the y value is going to change signs. Okay. All right, so let's try 1 over x squared now. Okay. What about 1 over x squared? So let's see. Let's make the table over here, right? We get 1 over x squared when we plug in some values, right? When x is 1, we get 1. When x is 2, we get 1 over 2 squared, which is 1/4. When x is 3, we get 1/9. Okay, so it's sort of similar, right? Not exactly the same values, but we notice that in this case, we are still going to get closer and closer to the x-axis, right? But we're never going to actually touch it, right? Okay. We notice once again when x is 0, Okay, we're going to get does not exist. Okay. But notice what happens when x is negative here, right? Well, wait a minute. When x is negative, we're going to square that, so we actually get a positive 1. When x is negative 2, right, we're going to get a positive 1/4, okay? So let's think about that, right? What is that graph going to look like then, okay? So it's going to look sort of similar to this one, to the graph of 1 over x. We don't need to draw a whole lot of hash marks because we can sort of determine what the graph is going to look like, right? But our graph should look something like this. It's going to look sort of similar, right? Not exactly the same. Okay? But notice what happens on the left side when x is negative, right? We're going to get something that looks like this. So what can we say about this graph? Where is this function increasing? And as we go left to right, you notice, well, wait a minute, these y values are getting larger and larger, right? So as we're going left to right, this function is increasing from negative infinity to 0. And this function is decreasing then from 0 to infinity, right? So remember, as we go left to right, these y values are getting smaller. So we give the answer in terms of x, right? These answers, okay, refer to the x values in question, right? Now, does this graph show any reflective properties? And the answer is yes, right? This is reflective across the y-axis here. So we do have y-axis symmetry. So the y-axis acts as the mirror here, okay? Which means what? Which means that this is an even function. Okay, this is going to be an even function. Okay. All right, so just by looking at the graph, hopefully you should be able to determine, right, intervals of increasing, decreasing. You should also determine if there's any symmetry, right? And from the symmetry, we can determine if this function is going to be even or odd.